Now, in the last lesson, we looked at how Swift tuples work, and now we're able to use it inside this else if statement to be able to store the first number of the calculation and also the operation of the calculation. So right at the top here, let's create a brand new variable that is going to be our intermediate calculation. Now, as a challenge, I want you to create this as a tuple that can store a string and a number that corresponds to the first number that the user is going to calculate with and also the operation. Now, remember all of the things that we spoke about in the advanced Swift section and try to create this tuple so that it complies with all of the best practice. Pause the video and give it a go. All right, so here's our tuple up here, and we're not going to give it any values up here when we initialize our structure. So we're only going to specify its data type. And remember, we specify a tuple's data type with a set of parentheses. Now, the first item inside our tuple is going to be the first number. So this is going to be a double, and I'm going to call it n1. Now, the second thing we need to store in here is the calculation method. So I'll just call that calc method, and this is going to be a string. Now, I don't actually have a value for this tuple when I initialize my calculator logic structure. So I have to be able to set it to nil when I create calculator logic. That means I have to turn it into an optional. And I do that by just adding a question mark to the end of the entire type, right? So in this case, the type is a double, and so the question mark goes at the end of the double. But in this case, the type of the tuple is all of this, and so the question mark goes right at the end. Now, if instead you'd added the question mark here, then that means you can create tuples that may or may not have an n1. And if you created one here, then that means you can create a tuple that may or may not have an n1 or a calc method. Now, that's not what we want. So we're going to delete those two, but we're going to keep the entire tuple as an optional. Now, the final thing to consider is, remember, whenever we're creating global variables, to start it out as a private var. That way, we prevent other classes from messing with our intermediate calculation, and certainly no other class or structure actually needs to be able to modify our intermediate calculation. It's a bit of data that we've saved right in the middle of something we're doing inside calculator logic, so we have to defend it from other people accidentally changing or modifying it. So now that that's done, we can head over into this else if, and we can set our intermediate calculation. And I'm going to set it equal to a tuple, so a set of parentheses. And then I'm going to tap into n1. Now, I find that Xcode is not great with autosuggest when it comes to tuples, so I like to type it out just manually. Now, n1 is going to be the number that got passed over with the calculation, so that is equal to n. And then the next thing is the calc method, and this is simply going to be the symbol that got passed in when this calc method was called. So now we have set our tuple inside this else if. So that means when a user taps on a number and then taps on one of the calc buttons, we'll pass over the number as well as the calculation method over to our calculator logic. And then it's caught inside here if it was a plus sign that they pressed. And we save that plus sign along with the number inside our tuple that's called intermediate calculation for later use. Now, at this point, Xcode again tells you that self is immutable because we're inside a struct and we're changing one of the properties here. So therefore, we have to mark this as mutating. So in order to succeed at this challenge, you actually had to have remembered a lot of the things that we discussed in this module. So if any of those things were at all confusing, be sure to have a look back at some of the lessons previously where we discussed access levels or structs and classes and some of the advanced Swift best practice. So now we have to address what should happen when the user finally presses the equals button. Well, at this point, we should trigger the entire calculation and use what we saved inside the intermediate calculation, right? So let's go ahead and call another method in here, which we'll call perform toNumber calculation. And this method is only going to have one input, and that is going to be the second number that we're performing the calculation with, which is again going to be a double. So that number in this case will be n, right? Because when the user has pressed the equal sign, then that means we passed in the second number that they tapped on. So let's go back to our calculator. When I press on 5 and then plus, then the calculate method gets triggered and we fall into this else if bracket where we set our tuple intermediate calculation to equal the first number that I typed, which was the 5, and the calc method, which is this plus symbol. Now, once that's done, that gets saved and stashed away, ready for the next number to come in. And at this point, let's say I press on 3 and then I press equals, and I expect an answer at this point. So then the calculate function gets called again, and I catch it inside this else if statement because the symbol was the equal sign. And then I call a function that will perform the whole calculation, passing in the second number that it needed to add to the first one, which happened to be 3 in my example. So let's go ahead and create this function called perform to number calculation. And it expects a parameter called n2, which is going to be a double, and it's going to return a double as the output. And this functionality is internal to our calculator because it performs the second half of the calculation. And so this shouldn't be called by anybody outside this current struct. So we can mark this method as private as well to prevent from any other classes or structs from accidentally calling it, because it will surely create an error. But inside this function, we're going to group together all of our intermediate calculation that we saved into our tuple. So because our tuple is an optional, then we have to unwrap it or use optional binding to check to make sure that we definitely actually have values for it. Because if the user simply pressed the equal sign right at the beginning by accident without having any operation specified or any number specified, we don't want our app to crash, right? So let's create an if let, and let's say that if let n1 equal intermediate calculation dot n1, and then we can do the optional binding calc method in the same line by simply adding a comma. So if let n1 equals intermediate calculation dot n1, and also let operation equal intermediate calculation dot calc method, then and only then do we perform the code inside this block. So you can see that if I split this code into two lines, we're creating two constants. One is called n1, one is called operation, and we're creating it by optionally chaining intermediate calculation. So we're saying if intermediate calculation is not nil, that's what that question mark says, then tap into the n1 value inside it and bind it to this thing called n1. And if intermediate calculation is not nil, again, grab the calc method out of it and assign it to our operation. So now that we've got n1 and operation both unwrapped as non-optionals, we know that they're definitely not nil, then in this case, we can complete our calculation. So we can say that if the operation was equal to plus, then in that case, we should return as the output n1 plus n2. And that is our addition functionality. So if we have a look back at our if statement over here, it doesn't make sense to check for plus, minus, times, multiply, divide over here if we can do it separately over here. So what I'm going to do is I'm going to cut that else if statement and I'm going to put it in as an else instead. So that means that if the symbol that was passed over was not any of these simple calculations, and it wasn't an equals, then everything else, namely plus, minus, multiply, divide, should be caught inside here, and we should create an intermediate calculation. because everything else that remains other than these three and this button is going to be a 2-number calculation. And we're going to store the actual symbol inside this calc method inside our tuple. So once the user presses the next number and they press equals to get the result, then we perform our 2-number calculation, which is a private function, so it can only be called within this current structure, not from outside. And we complete the operation by checking to see which one needed to be performed, and we return the result. So now Xcode is telling us that this result is not handled over here. So how should we handle it? Well, of course, we're going to return it as the output of this function, right? So as a challenge, I want you to complete this part where we check for all 4 different operations, plus, minus, multiply, and divide, and specify what should be returned. Now, because we've got 4 things that we're checking, it doesn't make sense to have it as an if statement. So as a part of the challenge, I want you to change this to a switch statement, so you can switch on the operation that needs to be performed. So pause the video and go ahead and give that a go. Okay, so let's change this if to a switch by changing the keyword. Next, let's delete all of this and all of this. So we have a blank switch statement and we're switching on the operation. So let's address some of those cases. In the case where the operation is equal to a plus sign, then we want to return n1 plus n2. But in the case where the operation was a minus sign that the user wanted, then we're going to return n1 minus n2. Next, if the case was a multiply, and I recommend that to get the symbol for the multiplication, you head over to the main storyboard and just double click on that multiply button to copy the text that's in there. Because unless the Unicode is exactly the same, then this won't work. So now that we've got the multiply symbol in there, we're going to go ahead and return n1 multiplied by n2. And finally, we're going to address the division, which again, I'm going to copy from over here. And I'm going to paste it right here. So the last case, we're going to return n1 divide by n2. And as with all switch statements, you should always have a default case. And this just catches out the cases where your operation that's being passed in does not match any of these. And in our case, that would be very, very weird. But we should still catch it, and we should throw a fatal error because it's something that should never really happen. And in this case, we're saying that fatal error, the operation passed in does not match any of the cases. So we'll know what's happening at that point. Now, as you can see, we've had this error screaming at us for a little while now. And it's saying that we're missing a return statement in a function that's expected to return double. Now you can see we've got lots of return statements, right? So why are they being so hard on us? Well, it's because we've got these if-lets. And that means that there's cases when these would fail. For example, if the user opens up the app and the first thing they do is they tap on the equal sign. Well, in that case, we're going to call our perform 2-number calculation, and there might not even be an intermediate calculation yet, right? Just because they tapped on it by accident. Well, in this case, we shouldn't crash the app. We should instead just ignore it. So how do we do that in code? Well, we can simply return nil, because there is nothing to perform our 2-number calculation with. Now, in order to be able to return nil, we can't specify that this method only can output doubles. It has to be able to output optional doubles so that we can return it as a nil. So in this case, if they accidentally tapped on the equal sign, we call perform 2-number calculation. This turns into nil. We return nil as the output to our calculate method. And over here, we catch that inside this guard statement, which, if you notice, is again a fatal error, which will crash our app. So this is a really good point to talk about what is the difference between a guardlet and an if-let, because you'll see them all over the place in a lot of the Swift code out there in the wild, but it's really difficult for an intermediate or a beginner Swift programmer to understand just when to use a guardlet versus an iflet. And this is a perfect illustration. Well, in this case, when you use a guardlet, it means that you're guarding against something terrible, right? In very few cases do you expect this else to be triggered. That's what a guardlet is used. We're guarding against really bad things from happening. That should never really happen unless we had some sort of brain freeze and we completely screwed up our code. Now, if we're using an iflet instead, then that means that we're expecting that 9 times out of 10, this will not be nil and we will be able to trigger this block inside here. But we're also accepting that sometimes it might just be nil, and that's fine. We don't have to do anything. We can simply ignore those cases. So now that I've changed that guardlet to an iflet, and only when I get a non-nil value from my calculation do I update my display value, then that means that if the user has accidentally tapped on the equal sign without any prior numbers or prior operations, then we don't crash our app. Instead, our code just ignores it. So this is a really good illustration of why you would use guardlet versus iflet. And I recommend that if you really want to get down to the nitty-gritties of it, try changing it around and run the app and see what happens for yourself, just so that you can get first-hand experience of what I'm saying to you. Alright, so our app is pretty much done. The last thing that I'm going to change is just to make this set of if statements into a switch statement, just to clean up our code. So now we're ready to test our app and see if it works exactly the way we expect it to. So let's try 9 times 2 equals 18 plus 6 equals 24 divided by 4 equals 6. Clear and percentage. Everything works perfectly. Now, there's a lot more that you could do to this calculator by adding extra buttons, extra functionality. You could make it into a graphing calculator if you really wanted to, or you could make it more robust and more reliable in terms of the code as well. But I hope that this has been a fun and interesting project, and along the way we've learned about access levels, structs versus classes, mutating functions, how to use the self keyword, internal and external parameter names, Swift tuples, and so much more. So as you can see, it's a jam-packed lesson full of advanced Swift concepts. So now that you've reached this stage in your development journey, it's really important that if there's anything that you don't fully understand, or if there's something that you want to learn more about, then be sure to do some extra reading, and especially by reading through the Swift Programming Language online book, which you can access at docs.swift.org/swiftbook. And you can look through it and read up on the parts that we've covered and try it out yourself, just so that you can make all of the knowledge in the tutorials your own. So it's all from me, Angela at the Appbury. So till next time, guys.